If you remember when you have a converse, the converse flips the first and the second part statements. So the if becomes the then and the then became the if. So we had the corresponding angles postulate, which told us that if you had two parallel lines and they're cut by a transversal, then the corresponding angles are congruent. Which we have now is if you have two lines that are cut by a transversal and the corresponding angles are congruent, then that means the lines have to be parallel. So before we had parallel lines give us congruent angles, now we have congruent angles give us parallel lines. So it's just going in the opposite direction. So what we have is if angle 1 is congruent to angle 3, angle 2 is congruent to angle 4, angle 8 is congruent to angle 6, and angle 7 is congruent to angle 5, then, oops, I forgot to name the lines. We'll say A and B. A is parallel to B. So before it was parallel gave us congruent angles. Now we have congruent angles give us parallel. So again, we're just talking about the corresponding angles right now. So 1 and 3, 2 and 4, 8 and 6, and 7 and 5. Okay, so then we have the parallel postulate, which tells us that if we have a line and a point that's not on the line, so anywhere out in space, there's exactly one line, so only one line that can be drawn through this point that will be parallel to the line that we started out with. So if I go and I attempt to draw a line through the point, this one is parallel, but if I draw any other line, it will not be parallel. There's only one line that will exist through that point that's parallel. All right, so now we have these theorems that we can use to prove lines are parallel. Now when I say we're going to prove lines are parallel, I don't mean we're going to write proofs. We're just going to do calculations to show that lines are parallel. Okay, so there's 4 of them. Okay, so these are all converses again. So we used to have that if you had two parallel lines, oops, I wrote interior when I should have written exterior here. That's okay. If you have two parallel lines and they were cut by a transversal, then they gave us congruent alternate exterior angles. Now we have, if you have two lines and they're cut by a transversal and the alternate exterior angles are congruent, that makes the lines parallel. So it just goes backwards. Before we had parallel lines, gave us congruent angles. Now we have congruent angles, give us parallel lines. So we're just moving in the opposite direction. So if I have two lines that exist and then I cut a transversal and then I look at these angles here or these angles here, and I get that angle 1 is congruent to angle 2 or angle 3 is congruent to angle 4, that would mean that lines A and B are parallel. Okay. Sort of the same idea. We have two lines in a plane hanging out. I'm going to call them M and N this time. So M and N are hanging out. And then along comes transversal T. And we get consecutive interior angles. So we're going to be talking about angles 1 and 2 or 3 and 4. And so we get that if measure of angle 1 and the measure of angle 2 equals 180, or the measure of angle 3 plus the measure of angle 4 equals 180, then M is parallel to N. So if these add up to 180, the lines are parallel, or if those add up to 180, the lines are parallel. Okay, so again, this is another flip it around thing. So we have if two lines in a plane, so What shall we call these lines? Okay, Joe and Bob. Joe and Bob are cut by a transversal. And if we get pairs of alternate interior angles, so 1, 2, or 3 and 4, that are congruent, then Joe and Bob are parallel. So if angle 1 is congruent to angle 2, or angle 3 is congruent to angle 4, then Joe is parallel to Bob. And finally, we have the perpendicular transversal converse, which tells us that if we have two lines in a plane, Frodo and Bilbo, and they are perpendicular to the same line, then they're parallel. So if, let's see, I don't think I spelled that right, but if Sauron is perpendicular to Frodo and perpendicular to Bilbo, then Frodo is parallel to Bilbo. Can you tell I didn't get enough sleep? All right, so given the following information, is it possible to prove that any of these lines are parallel? So for number A, letter A, I've got 1 and 6 are congruent. Now if I look at these are alternate exterior angles, right? Because they're on the outside of two lines and they're on the opposite side of a transversal. So this will make Q parallel to S by alternate exterior. We don't know about R yet. I can't say anything about R because I don't know anything about these two yet. So I have 1 and 6, so that's Q and S. Now for 2 and 3, these are alternate interior. This is what will let me know that Q and R are parallel. So Q is parallel to R because of alternate interior. Okay, so if we look at these 6, okay, so I have 2 and 8. So I'm going to do C in red. So I have 2 and 8. These are on opposite sides of, I didn't put letters on the lines. So we'll say that's A and B and C and D. Okay. These are on opposite sides of A. That makes A my transversal. And they're interior of C and D. So these are going to be that C is parallel to D from alternate interior.
So if say 1 was and C was, so if say 2 was inside and 16 was outside B, would that be?
These two here won't have a relationship.
No?
No, because they have to be touching the same line. The two angles have to be touching the same line to have a relationship. So either they have to both be touching any one of these 4 lines, but 2 touches C and A, and 16 touches D and B, so they have no relationship because they don't touch the same line at any point. Do you see how 2 and 3 both, or 2 and 8 both touch A? So they have a relationship. Yeah.
In a test, or some type of exam,
Uh-huh.
that's a common mistake that people make with this, that they get the answers wrong.
I would say the most common mistake is not labeling or like somehow like using color or something, and so you don't see what's happening as well.
Because they're switching, like,
Yeah.
all the time. So
Yeah.
it could be any one.
So here, like this one, we'll do 3 and 11. Okay, 3 and 11 are both touching C. That makes C my transversal. The line that both angles touch is the transversal. So 3 and 11 are touching C. C is my transversal. And if you look now, that means I'm kind of comparing A and B. If I have my 4 squares, 3 and 11 are in the same spot. So this is a corresponding angles. So that tells me that A is parallel to B from corresponding angles. Okay, if I come now to, let's
Wait, you
do
say 3 to 11?
hot pink. Yeah, 3 and 11. 3 and 11 here.
Where's that?
It's right there. It kind of
Ah,
got
okay, okay. That's corresponding what?
corresponding angles, yeah. So if we go with the pink for 12 and 14, 12 and 14 are both touching B.
The exterior.
So that makes B the transversal, so they're exterior and they're on opposite sides. So that makes C parallel to D for alternate exterior. Okay. Let's do green. I have 1 and 15.
So for
Okay,
D,
now look at this, 1 and 15.
One's exterior, one's interior.
Well, but no, it's not just that. Angle 1 touches A and C.
it's not.
Angle 15 touches B and D. So we can't prove anything.
And for D, the corresponding it equals to 180, right? Or not?
For D?
Yeah.
No, corresponding angles are congruent.
Okay.
Consecutive angles interior are 180. So corresponding are in the same position in like the 4 square. And then if I had 3 and 10, 3 and 10 would have to add up to 180. Does that help? So do you see why 1 and 15 don't prove anything? Because they don't touch the same line ever. So they can be congruent all they want. It doesn't tell me anything because they have no relationship. You have to be touching the same line to have a relationship. Let's do purple. 8 and 13. Here's 8 and here's 13. They're same side interior. They add up to 180, so that tells me that A and B are parallel because of consecutive interior angles. And finally, orange, 8 and 6. Okay, 8 and 6 are vertical angles, but vertical angles don't tell me a relationship between any lines. So these are vertical angles. No parallel relationship exists. So I can't prove anything with those either. So vertical angles don't prove anything, and angles that are not touching each other don't prove anything. Or not touching each other, I'm sorry, not touching the same line. You can only have corresponding angles, alternate exterior, alternate interior, or same side consecutive interior that add up to 180. Anything else doesn't prove anything at all. So there's only the 4 ways to show that 2 lines are parallel. Okay, we have problems like this where we have to find the x that will force these 2 to be parallel. So I want A to be parallel to B. So I'm looking at this angle and this angle. These are alternate interior angles, so I want them to be equal to each other. So I have alternate interior. I need them to be congruent. Okay, so I've got these 2 are alternate interior. So I want them to match, so I'm going to set them equal to each other. Okay. So then I'm just going to solve it. So 2x minus 21 equals 7, plus 21, 2x equals 28, divided by 2, x is 14. This is the only value that x can be that will make these lines parallel. Yeah.
I thought you set them like corresponding, that's why they give one zero.
Yeah, they'll always, for the parallel line part, they'll always be equal to each other or add up to 180. There's not going to be any other scenario.
So we've got
Yourself, if you want to, check your work, you can plug in 14. So I can do 5 times 14 plus 7, and 7 times 14 minus 21, and see if those are equal to the same thing, which I'll do right now. So 70 plus 7 and 98 minus 21. This is 77. That is 77. They match. You got the right answer. If we're perpendicular to one line, we have to be perpendicular to the other in order to be parallel. So that's 90. So I'm going to set this equal to 90. So 4y plus 10 is equal to 90. And subtract 10 from both sides to get 4y is 80. And then divide by 4. So y is 20. And again, you can check your work by plugging 20 in and making sure this equals 90. Okay, here we have alternate exterior, so again, they have to be equal. So 3x minus 14 is equal to 2x plus 25. Subtract 2x from both sides. X minus 14 is equal to 25. Add 14. And you get that x is 39. And then lastly, I have 2 on the same side on the interior, so these are going to add up to 180. So this is the only time that they should add up to 180 is if they're same side on interior. So 7x minus 2 plus 10x minus 3x equals 180. With this being the first angle and that one being the second. So 7 and 10x is 17x, negative, whoops. It would help if I wrote down the problem correctly. There's no x there. You guys are supposed to catch me when I do stuff like that. 7 minus 3 is 4x, negative 2 plus 10 is 8. Subtract 8 from both sides, and you get 4x is equal to 172, which you can divide by 4. And you get that x is equal to 43.